Welcome to Surds Level 5. One step in a level by level practice course. Pause the video now, try the problems on the screen, and I'll go through them with you shortly. At the end of the video, you can use the end screen to either practice more at this level or move up to the next one, and you can find topic by topic playlists on the channel homepage. In problem 1, we're rationalising and simplifying 4 over the square root of 3 plus 1. Now rationalising means that we need to remove the surd from the denominator, and when you have two terms in the denominator like we do here, we need to multiply by the conjugate of that denominator. And the conjugate of root 3 plus 1 is root 3 minus 1. So we keep it exactly the same, we just change the sign in the middle. And because we have two terms here, we need to make sure that we put these in brackets when we multiply. Now for multiplying the bottom, we also need to multiply the top to keep the fraction equivalent. So we're also going to multiply 4 at the top by root 3 minus 1. Now if we start with the numerator, we have 4 multiplied by root 3, which gives us 4 root 3, and then we have 4 multiplied by minus 1, which gives us minus 4. And if you'd like a bit more help with expanding brackets in general, take a look in the top right corner where you can see my course on expanding brackets. Now back to the problem, focusing now on the denominator, we can multiply root 3 by root 3, which gives us 3, because when we times a surd by itself, the square root part disappears. Then root 3 times minus 1 is minus root 3. 1 times root 3 gives us plus root 3. And 1 multiplied by minus 1 is minus 1. Now whenever we do this, if we've done it correctly, these surds at the bottom will cancel out. And we've rationalised because the surd parts have all disappeared. So the numerator remains as 4 root 3 minus 4, we can't simplify anything there, and our denominator is 3 minus 1, which just becomes 2. Now what we notice here is that the 4's on the numerator can both be divided by 2. So this means that we can simplify this further. So dividing each of the terms in the numerator by 2, 4 root 3 divided by 2 becomes 2 root 3, and minus 4 divided by 2 becomes minus 2. So 2 root 3 minus 2 is our final answer to problem 1. In problem 2, we're rationalising and simplifying root 5 minus 2 over root 5 minus 1. Again here, to rationalise the denominator means we need to get rid of the square root, and to do this we can multiply by the conjugate of root 5 minus 1, and that's just root 5 plus 1. We just change the sign in the middle. So we need to make sure these go in brackets because there are two terms here and we're multiplying, and we also need to make sure that we multiply the numerator by the same thing, so by root 5 plus 1, to keep the fractions equivalent, and so we also need this in a bracket. So starting with the numerator, we have root 5 times root 5, which just makes 5, because we're timesing a surd by itself, the square root part disappears. Next, root 5 times 1 gives us plus root 5. Then minus 2 times root 5 gives us minus 2 root 5. And finally, minus 2 times 1 gives us minus 2. Moving on to the denominator, we can do the same thing. So root 5 times root 5 just gives us 5. Root 5 times 1 gives us plus root 5. Minus 1 times root 5 is minus root 5. And minus 1 times 1 just gives us minus 1. And again, we can see that the surd parts in the denominator are going to cancel, which we want. So now looking at the numerator, we can simplify. So we have a 5 and a minus 2. So 5 minus 2 is 3. And we also have a root 5 and a minus 2 root 5. And this gives us minus 1 root 5, or minus root 5. On the denominator, our root 5's have cancelled out, so we just have 5 minus 1, which is 4. Now since neither the 3 nor the minus 1, which is in front of the root 5, have common factors with 4, we can't simplify this fraction anymore. So 3 minus root 5 over 4 is our final answer to problem 2. In problem 3, we're rationalising and simplifying 3 root 3 plus 3 all over 2 root 27 minus 6. Now it'll be fine to start rationalising straight away and do what we've done the last couple of questions by multiplying the denominator by the conjugate of 2 root 27 minus 6. And the conjugate is just exactly the same two terms, but with an opposite sign in the middle. So we would times it by 2 root 27 plus 6. And we can do the same with the numerator. An alternative approach to begin this is to first notice that the root 27 can be simplified, and actually rationalising then becomes easier if we have a smaller surd at the bottom. So I'm going to start by simplifying the root 27. So we know that 27 can be rewritten as 9 times 3, and 9 is a square number. So root 27 can be written as root 9 times root 3, and because the square root of 9 is 3, this becomes 3 root 3. So our original fraction becomes 3 root 3 plus 3 divided by 2 multiplied by root 27, which we can now write as 3 root 3 minus 6. And if we simplify that denominator again, 2 multiplied by 3 root 3 becomes 6 root 3. So we have 6 root 3 minus 6. Now that we've simplified, we're ready to rationalise, and we could actually simplify this fraction even more by dividing everything top and bottom by 3, but let's leave it as it is for now, and we're just going to multiply the denominator by the conjugate of 6 root 3 minus 6, which is 6 root 3 plus 6. And we need to make sure we do the same to the numerator and put all of these in brackets to make sure that every term is multiplied by every term that it needs to multiply by. So starting with the numerator, we have 3 root 3 times 6 root 3. Now 3 times 6 is 18, and root 3 times root 3 is just 3. So we get 18 times 3. Then we have 3 root 3 multiplied by 6. Well, 3 times 6 is 18, so this becomes 18 root 3. Then 3 times 6 root 3. Again, 3 times 6 is 18, so we get another 18 root 3. And finally, 3 multiplied by 6 at the end gives us plus 18. Moving on to the denominator, we have 6 root 3 multiplied by 6 root 3. Well, 6 times 6 is 36, and root 3 times root 3 is 3. So we get 36 times 3. Then we have 6 root 3 multiplied by 6. 6 times 6 is 36, so this becomes 36 root 3. Minus 6 times 6 root 3 becomes minus 36 root 3. And finally, minus 6 multiplied by 6 gives us minus 36. So focusing on the numerator, we can simplify. So 18 times 3 gives us 54. The plus 18 root 3 and the plus 18 root 3 can be collected together to give us plus 36 root 3, because 18 plus 18 is 36, and we still have a plus 18 at the end. Moving on to the denominator, 36 times 3 is 108, and we have a minus 36 at the end. So going back to the numerator, we can now collect together the 54 and the plus 18, and this gives us 72. So we have 72 plus 36 root 3. And then the denominator, 108 minus 36, gives us 72. Now this isn't our final answer because we can still simplify one step more. And if we notice, 72, 36 and 72 all have common factors, and have lots of common factors. They can all be divided by 2, by 3, by 6, by 9, by 18. And actually the largest factor, so the highest common factor of those numbers, is actually 36. So if we divide each of these by 36, starting with 72, 72 divided by 36 is 2, plus 36 divided by 36 is 1, so we just get 1 root 3 or just root 3. And then at the bottom, 72 divided by 36 again gives us 2. So our final answer to problem 3 is 2 plus root 3 all over 2. In problem 4, we're rationalising and simplifying 3 root 8 plus root 50 all over root 2 plus root 5. Again here, we could start rationalising immediately and multiply the top and bottom by the conjugate of root 2 plus root 5, and that's root 2 minus root 5. And it would be absolutely fine for this to be our starting point. However, an alternative place that we could start is by simplifying some of these surds, and that's where I'm going to start here. So we need to find two numbers that multiply to make 8, where one of them is a square number, and that's 4 times 2. So the square root of 8 can be rewritten as the square root of 4 times the square root of 2, and that's equivalent to 2 root 2. Similarly, if we look at 50, 50 can be rewritten as 25, which is a square number multiplied by 2. So root 50 is root 25 times root 2, and this is equivalent to 5 root 2. So this means that our original fraction becomes 3 times root 8, and instead of root 8 we have 2 root 2 plus root 50, and in place of root 50 we have 5 root 2, and that's all still being divided by root 2 plus root 5. Now if we simplify the numerator here, 3 times 2 root 2 is 6 root 2. We have plus 5 root 2, all divided by root 2 plus root 5. And we can continue to simplify the numerator by collecting together the 6 root 2 and the 5 root 2, which give us 11 root 2. So we have 11 root 2 over root 2 plus root 5. And although we haven't done any rationalising yet, we have really simplified that numerator, so hopefully now when we rationalise, it's a bit simpler to do. So to rationalise, as mentioned earlier, we're going to times by the conjugate of the denominator. So we're going to multiply by root 2 minus 5, so we just change the sign in the middle, and we need to do exactly the same on the numerator to keep the fractions equivalent. And brackets are needed around all of these here to make sure that we don't miss anything when we multiply. So starting with the numerator, we're going to begin with 11 root 2 multiplied by root 2. So we have 11 times, and root 2 times root 2 is just 2. Next, we have 11 root 2 times minus root 5. So this is going to be minus 11, and then root 2 times root 5 is root 10. Looking at the denominator now, we can do root 2 times root 2, which just gives us 2. Root 2 times minus root 5 is minus root 10. Root 5 times root 2 is plus root 10. And finally, root 5 times minus root 5 is minus 5. If we now simplify the numerator, 11 times 2 is 22. So we have 22 minus 11 root 10. And simplifying our denominator, again, the minus root 10 and the plus root 10 cancel out, which is what we want to happen. And 2 minus 5 gives us minus 3. Now, since 22, 11, and 3 have no common factors greater than 1, we can't simplify this fraction any further. So we can leave our final answer as 22 minus 11 root 10 over minus 3, and this would be fine. Having said that, it's often neater to not have this minus in the denominator. And what we can do to remove this is to multiply both the numerator and the denominator by minus 1. Again, multiplying top and bottom of a fraction by the same thing keeps a fraction equivalent. And what that's going to do is it's going to make our minus 3 on our denominator become a 3. And then our 22 becomes negative, so that's going to be minus 22. And our minus 11 root 10 becomes positive. So we just have an 11 root 10. And this is just a slightly neater version of the line above. So 11 root 10 minus 22 all over 3 is our final answer to problem 4.